This is Professor Murphy, your instructor here at Weber State University, and today we are going to talk a little bit about computer networks. We'll learn about what they are, and we're going to show you a few network layouts. We're going to tell about some of the devices that we use to create computer networks. First of all, a computer network is a group of computers that are all connected together. It has a purpose of sharing information and resources. The best and probably the largest example that you can think of a computer network is the internet. I'm sure many of you have a small computer network in your home, school, or work, or whatever. If you're up at Weber State, there's a computer network. Networks are classified by their size. The smallest network you can have is a LAN. It stands for Local Area Network. This is a network like in your home or in your office. Pretty much one building can be a LAN. Now, wide area networks could connect several local area networks together. So, since I'm in Utah, I'm going to give you a Utah example. I go to an IHC clinic and the doctor reads my information. Well, he records it in the network, and it doesn't matter where I go so long as it's in the IHC clinic. Whatever doctor that I have can have access to that information. IHC has a wide area network. It spans over multiple buildings around all of Ogden, and I'm not sure how far IHC goes, but you get the idea. There is a metropolitan area network, or MAN. This is a geographic region. It could span several buildings or the entire city. It's larger than a LAN, but smaller than a wide area network. So here we have the diagram from your book. It shows a couple of local area networks, which are just a few computers connected to some type of gateway, and the two LANs are connected through a satellite dish to make the entire diagram a wide area network. And part of connecting the network is the actual physical paths, or guided media. We're going to talk about coaxial, UTP, and fiber optic cable types. Coaxial it's copper wire. The problem with wire is it's affected by noise or disturbances. The noise could be wiring or equipment, even the sun, anything can affect that. So it's protected with a metallic shield, and there's some plastic insulation in there that'll increase the bandwidth and get rid of some of the noise. Now this is probably what most of you have seen coming into your computers in your office or whatever. UTP, or unshielded twisted pair. It consists of copper wires, but they're twisted. If you have parallel wires in their close proximity, you might have an electrical current wire that induces a signal on the other wire. And with electricity, it's a good thing. You want to have the electricity going through the same direction. But in data transmission, it's a bad thing. Your information could get corrupted or overwritten. So twisting the wires prevents the induction from happening. Fiber optic does not use copper wires at all or electrical signals. Instead, it's bundles of glass surrounded by plastic, and it transmits data in the form of pulses of light. It's a much faster transmission, but it can be more expensive to manufacture. More and more, this is becoming the most popular because of its speed. Unguided media is when your device is not limited to a wire. There's several wireless technologies that let you connect to your network. Bluetooth, WLAN, you can connect two LANs together with a satellite. WAP, or cell phones, can connect to the internet. And all of these technologies use electric signals, which are amplified from some sort of antenna. They're amplified as waves. They travel through the air, and they're picked up by another antenna. It's converted back to an electrical signal. Protocols are rules that govern communication over your computer network. We have protocols for communication as well. Before you can talk to someone on the phone, you have to dial the correct number. If you dial a different number, you may not get the person you want to talk to. Now, when the phone rings, you answer it. You're not going to answer the phone before it rings. That's the protocol in our culture, is to say hello when you answer the phone, or some sort of acknowledgement that you're listening. And the same is true for computers over the internet. There are protocols that they have to follow in order to communicate with other computers. The OSI model is a standard for different types of computers to communicate with each other. Data uses each layer of the OSI model as it travels from its source to destination. One way to remember the OSI model is to say the following. All people seem to need data processing. It's just a little mnemonic device. You can take the first letter of each letter in the sentence to give you the letters to remember for the OSI model. I'm going to demonstrate a little bit how the OSI model works. Suppose we have an email ready to go out. The email has an application, and the application has access to the network. She's using this application to write her email. The presentation layer formats the data so it's ready for transport. Now, really, her email message was already in binary as far as the computer is concerned, but you get the idea that the message needs to be encoded. The session layer of the OSI model establishes a connection between the two computers. The transport layer gets the information ready to send over a network. Okay, imagine you are driving down I-15 during rush hour traffic through Salt Lake or wherever that construction site is, and everyone's slowing down and slowing down. Now imagine, instead of being in a car, you are in a train, and everybody's driving trains. Just think of the traffic that's going to be happening on I-15 if everyone was driving trains. Okay, now we're going to compare this to the internet. All of these pieces of information going down a network would be like a train of information taking up space. So instead of sending the entire message when you send an email or when you send data over a network, it breaks the message up into packets or datagrams, and this is for transport. And each of these packets can take a different path to get to its destination. Much like we can, if I'm going to Salt Lake, I can take I-15, I can start on Highway 89, I can go down the Legacy Highway, just different paths, and each of these packets eventually arrive at their destination. The network layer is responsible for selecting the path which the packets travel. Not all the packets are going to travel, as I said, along the same path to get to their destination. The data link layer ensures that the packets reach their destination. Physical layer is the electrical link between the two systems, such as the actual cable. And now we see how the network works. Let's talk a little bit about different arrangements or topologies of networks. In this class, we're going to cover bus, ring, and star topologies. The simplest topology is the bus topology, or where all of the network is along one cable. There's a terminator at each end of the cable so that the signal doesn't bounce back and resend itself to the other computers. The advantage is it's easier to connect all the computers and requires much less cable. A disadvantage to this topology is that when the cable gets shut down, that affects the entire network. A ring topology connects one computer to the next until it once again connects back to the first computer. This type of network doesn't need a terminator, and there's much less chance of data collision than on the bus network. A star topology is when each of the computers are connected to a centralized hub. This type of topology is a little bit more expensive than a bus or a ring, but it performs a lot faster. In order to get the network set up in their topologies, there needs to be some sort of communication devices or hardware that will connect the computer networks. The NIC card, or network interface card, is usually an expansion slot on the motherboard. It will have some sort of port for attaching your cable. A signal decreases as it travels through the cables. This is called attenuation. A repeater amplifies the signal along the cable between the nodes. That way the signal stays strong. A hub is basically a multi-port repeater. It has several places where you can plug in different nodes, and it's used to amplify the signal. A switch is a hub's smarter brother, I guess you could say. It still has multiple outputs and it still amplifies the signal, but it also examines the data as it comes in and forwards the data onto the correct port. Now, a bridge will allow you to create a single network from multiple network segments. It's different from the router, which allows multiple segments to communicate while remaining as separate networks. Gateways are similar to bridges, but they have an additional skill that they can interpret different network protocols. They're used to connect different networks of different types. A router is used to connect the network. It also forwards data packets between the computer's networks. A firewall is designed to protect the internal network from damage from the external network. Now you know a little bit more about networking, the layouts and the devices you need to connect the network together.